Hi, it's Mr. Luneski here, and we are looking at Unit 10, Section 3. We are looking at inscribed angles. What's it all about? Let's take a look. Again, if you'd like, you can pause the video here to kind of copy down some of the vocab. For inscribed angles, an inscribed angle is any angle where the vertex is on the circle and the sides are chords. So key word here is on. The vertex meaning kind of where the angle is created. So if I drew something that looked maybe something like this, A, B, C. Now notice it doesn't go through the center of the circle, and that's fine. Inscribed angles don't have to go through the center. And I could say that angle ABC is an example of an inscribed angle because the vertex is right here on the circle. And then AB is a chord, BC is a chord. An intercepted arc is the arc that is between the sides of an intercepted angle. And so if this is my intercepted angle, the way I've sort of described this in the past is if you pretend like this is the cone, where do I put the ice cream? So the ice cream goes right here, inside the cone. That is my intercepted arc, and so I would say that arc AC is an example of an intercepted arc. And so we're going to look at some problems on how exactly to solve for either the intercepted angle or how to solve for the intercepted arc. And so the equation, kind of in words, is the arc is equal to 2 times the angle. And so that's kind of the rhythm that we're going to be using for a lot of these problems, that arc equals 2 times the angle. So there are a couple of different ways we can present how these problems look. So for example, if I had something here where this is angle 1, and let's just say that angle 1 was 25 degrees. And if I asked you to solve for arc AB would equal arc equals 2 times the angle. So I would say arc AB equals 2 times 25. And so the measure of this arc here would be 50 degrees. So that's one approach, is if I have 2 chords. Another approach is if I have a tangent and a chord. So remember, the tangent line touches the circle at one point, and then a chord sort of just goes through the circle. Again, it doesn't have to go through the circle through the center. So angle 1 and angle 2 in this example are a linear pair. Therefore, these angles are supplementary. Again, meaning 1 plus 2 is going to equal 180. And so, for example, let's just say that this was equal to 150 degrees right here, angle 2. Well, then we would know that angle 1 would have to equal 30 degrees. And then if I said solve for arc AB, arc AB is this. Remember, it's a minor arc. And so again, I do arc equals 2 times the angle. The angle on the intercepted arc there is 30, so 2 times 30. So arc AB would be 60 degrees. Another approach that you can kind of take to that is if I know that this is 60 degrees and I asked you find arc ACB, so ACB is the major arc, I can just do 360 minus 60. And that will tell me that this part here is equal to 300. And if you notice, 300 divided by 2, that's equal to 150. So 2 times the angle equals the arc. So it all works out. Whoops, wrong page. Move forward. All right, we're going to talk about a couple of different theorems that we can kind of use this information about. If I have a right angle inscribed in a circle, so meaning the vertex on the circle creates a right angle, then the hypotenuse is going to be the diameter. And the reason that we can say that comfortably is because if this is where my inscribed angle is, 90 degrees, we said that arc equals 2 times the angle. Well, if the angle is equal to 90, 2 times 90 is 180. And from what we learned last section, 180 is a semicircle. And so that converse is actually true as well. And so it says if angle ABC equals 90, if and only if AC is the diameter of the circle. So if I have a diameter, I can say that the inscribed angle is 90 degrees. And again, if AC is the diameter, then we can say that angle ABC is a right angle, and we can say that AC is a semicircle, or arc AC, excuse me. Another theorem is that if two inscribed angles of a circle intercept the same arc, then the angles are going to be congruent. So in this example here, we sort of have like a little bow tie inside of a circle. It says that the intercepted arc for angle D and angle C, that's going to be AB. So if we look at angle C is this right here. And that's intercepting this arc. That's where the ice cream goes, so to speak. And angle D is this angle here. And if you notice, it's also intercepting that same arc. And so since they intercept the same arc, we can say that the angles are equal. And because they intercept, the same arc. So because they're intercepting this same part here, that means that angle D has to be equal to angle C, or congruent. Another theorem states that if a quadrilateral, remember quadrilateral means it has four sides, any four-sided shape can be inscribed in a circle if and only if its opposite angles are supplementary. Supplementary meaning it adds up to 180. So it says the points D, E, F, and G lie on circle C if and only if. So the opposite angles, so E and G and F and D both have to equal 180 when I add them together. So that's how we can tell if a quadrilateral will be inscribed in a circle, is if those opposite angles add up to 180. Here are just some example problems now of sort of what we're looking for when we go to solve. So it says that given arc DB is equal to 60, find the measure of angle DAB and the measure of angle C. So essentially I'm solving for this angle and this angle. So hopefully what you notice is that angle DAB is a central angle, and that angle C is inscribed. So what we talked about last section was that inscribed angles, central angles have the same measurement as the arc. So if this is 60, this has to be 60. So DAB would be 60, and then what we just talked about is that the arc equals 2 times the angle, and while we're solving for the angle, so now we have 60 equals 2 times the angle, and if I want to solve for the angle, just divide by 2, so we can say that angle C is equal to 30 degrees. The next problem says that given QS is a diameter, so we know that this is a diameter, they want to know what angle R is. So what we talked about in one of our theorems is that angle R is intercepting this whole arc here, so it's intercepting half of a circle. It's 180 degrees, therefore this has to be 90 degrees. Problem number 3 says given arc DC is 110 degrees, find AC and find AB. So angle A is intercepting DC, and angle B is also intercepting DC. So they intercept the same arc, which means that the two angles should be equal to each other. Once again, we're going to use the formula arc equals 2 times the angle. So for this one, we have the arc. The arc equals 110. We're solving for the angle, so divide by 2, and we can say that the angle equals 55 degrees. So that would be both for angle A and for angle B. And finally, here are our problems. We have quadrilaterals inscribed into a circle. And so that means, again, that the opposite sides, or opposite angles, have to add up to equal 180. So to solve for x, we basically do 180 minus 88. Whoops, not 80, 88. And we get that x is equal to 92. And then to solve for y, we would say 180 minus 100. And we would say that y is equal to 80. So those are our two answers for x and y. And then finally, this last one here, a little bit different. So we can't just subtract from 180. So first we'll solve for, I don't care, x. So we can say 8x plus 4x equals 180. So that ends up being 12x equals 180. Divide both sides by 12 and you get an answer of 15. And to solve for y, we would say 3y plus 3y equals 180. 6y equals 180. Divide both sides by 6 and you get y is equal to 30. Alrighty, that is it for the video. Make sure that you are kind of getting ready yourself for the daily quiz. We have one more section after this and we are done with circles. Thank you for watching.